Hello everybody, my name is Borsha and let's continue with our AMD Versal Edge Generation 2, let's say system on chip system or controller, which is used in automotive industry and robotics and different other applications. So the system on chip includes the following features. In previous video we mentioned first two sections, which was I think um, let's check shortly. It was APU and RPU, so application processor unit and the real-time processor unit. Now we are describing the section PMC, platform management controller subsystem, which includes PPU, platform processing unit based on the microblaze processor. We gotta see what is this microblaze processor and the full description of it, but we will do it in further videos. Also provides system software boot and system on chip. These PMC platforms include security units, also triple module redundant microprocessor for safety. Also, it's unclear for now what it is because it's not obvious at this point. So we have also PLM platform loader and management firmware for flexible, fast and secure boot. Also boot interfaces, flash, JTAG, SMAP for boot development and operational modes. Also we have a CFU PL configuration frame unit with full and partial dynamic reprogramming of the programmable logic. This is very interesting. So configuration frame unit is probably in charge for the programming this programmable logic part of the system on chip. So we gotta see further what exactly that does this mean. System monitoring and device power management. This is also very interesting, probably one section which is important inside of PMC. Also flash memory and input-output peripheral IOP controllers. It's classical like uh, systems for uh, systems for which are in charge for the loading and transfer data, probably some kind of something similar to the DMA controllers, and probably directly to drive data from input to the memory, to the flash memory. System watchdog timer. We see again, even in this section, we have watchdog timer. Also, security units are included in this PMC. AXI main switch and the EOP switch with memory and peripheral protection units. For now it's unknown, but we will see in further pages what does this exactly mean. Located in the LPD for constant system monitoring even in a low power state. Somewhere it is described what is this LPD. I think I flash it. Probably it's on the other side, on the other slide. So LPD. It doesn't matter. Probably we mentioned somewhere, but I think it's low power. Yeah, a low power domain. Probably. Some part of the logic is in charge for the low power domain. We will see in further texts and description what it is exactly. Also, beside of that, system on chip includes the following features. Yes, it's ASU or Application Security Unit subsystem. We will see in one diagram these different units inside the device, how they are let's say put it in frame and the main functionalities. Redundant lockstep microblaze, again a microblaze RISC-V processor for secure robust execution. ACU firmware, okay, which is logical downloaded by the PMC, which is mentioned in the previous uh, point, which was point 3. Runtime security services for application software. So it seems that we have application level and the firmware level for this system on chip device. So if we have application level of the software, it means that this device is, let's say, more not complicated, but much more developed and have richer software interface, which is more human than basic firmware. So also located in LPD, low power domain. So it means that the ACU is located, this application security unit is inside of this LPD, low power domain. We will see on diagram what this exactly means. Also system on chip power domain subsystem or SPD. So that there is part of the system on chip which is in charge for the power supply of subsystems, I guess, and in charge of energy management inside the system on chip. Includes NOC, which probably means network on chip, and DDR memory controllers. So there is one network on chip controller inside this power domain subsystem, and DDR memory controllers probably in charge for the input and output some data inside the DDR memory. Expensive NOC NOC interconnect for processing system, also programmable logic fabric and integrated hardware options. So it says on the one side there is a network on chip part, which is interconnected with the PS and PL subsystems inside of system on chip. Multiple DDR memory controllers, we mentioned that. But this is with inline IS data encryption and ECC. I don't know what ECC means, but IS is a method of encryption. One of the standard methods of encryption in modern days. Even microcontrollers have special cores dedicated for this function. Chapter 6, Scalable Programmable Logic, or PL with fabric, logic units, DSP, and memory arrays in the Programmable Logic power domain. So there is section there is section which is programmable logic, and inside of that we have different logic capacities to develop inside of it, and some resources we can use and put it in way we want. So in further chapters we gotta see how it's done. Also it includes a graphics processing unit, GPU. We can see that it's not in the first rows, but there is nothing special said for now here about this. Maybe it's not significant role like in Orange chip, but we will check it out. What is the capacity and capabilities of the GPU or graphic processing unit inside the AMD Versal. And standard LVC MOS input-output gigabit transceiver. We will check in full what does it means, but not at this point. It's maybe important just to mention it for now, just to remember that we need to take care about it. So the main topics, main functional topics, so APU functional units, RPU functional units, PMC functional units, and ACU subsystem. Above mentioned in previous slides. So firstly, we shall focus on this and make a little overview because this is the main functionalities inside this AMD Versal system on chip. Here we have some diagram. We say we have PS, which is processing system. It's this part, and close to it we see that we have graphic processing unit, which is mentioned a few seconds ago. High-speed connectivity, so it is interconnect with the of this processing system, interconnection with the high-speed connectivity, which is 10 gigabyte Ethernet port, USB 3.2 interface, PCIe generation 4, which is very interesting. It's a pretty strong PCIe connection and port. So this is in charge for this section is in charge for the connection of the processing subsystem with some other things. It's not clear here what is also interconnect with, but we will discuss it later. Also, second chapter was RPU. We see here what we have. We say I think it's R52 main cores, and there is 10 of them. We see here 5. We have different memories and so on. So APU subsystem and RPU subsystem is a part of the one big processing system, which is interconnected with the graphic processing unit and the high-speed connectivity unit. Also, programmable logic, which we were mentioned. We see here that we have two sections. PL programmable logic is marked with this orange. Image signal processor 3 times multi-stream. So we see that here is a very that signal processor is a significant part of this programmable logic, and this is mostly made for the videos. Super logic regions, logic cells, digital signal processors, block RAM, ultra RAM, different kinds and different stories. For now it's unknown, but let's make some introductions. Initiate logic units, microblaze. Oh, there is the microblaze which is mentioned. System cache options, custom compute engine, peripheral controller, interconnect, local memory. We gotta see this all these options separately. I/O pins. So we have I/O pins which are part of the programmable logic, and the last chapter that we mentioned is named here LVC MOS for the I/O pins, transceivers, which kind of transceivers, and we have here input output. So we can say that programmable logic is somehow interfacing with another with the external world through these IOEs and through these GTs. I'm not sure for now what is GT, but we will check it out. Third chapter was the PMC subsystem, and we see that JTAG is inside the PMC subsystem, debug packet controller, again GTs. So we have GTs here, here, and here. For all three significant sections we have GTs, and we gotta check it. We see here that let's finish with the PMC subsystem. Also different peripherals, general purpose input output pins. So I'm guessing that this is fixed part. Also I2C type of connection, also flash memory controllers, and so on and so on. Security units. Okay, we see IS. We see that this part is in charge for the encryptions and types of encryptions, which is in charge. We see here that we have even RSA option for the encryption beside the AES. This is more like internal communication. That's my point of view. This is more like uh, internal communications or short path signal communication, like between the two chips on the board and so on. But this is more significant and let's say long distance and very used algorithm for the encryption. We have here also DMA, direct memory access controller, I guess, secure stream switch. I don't know what is this. So GT is debug packet controller. I don't know. I'm not familiar with this. We have ROM. We see here it's a little bit blurry, but also what is this section heavy inside of it. Platform processing unit, platform loader, and manager firmware. So monitors, events. So this is something in charge of inside processes, I guess. And we have firmware here. Also, we have ACU system or subsystem here. We have ACU processor runs ACU firmware 32-bit microblaze RISC-V. So let's go again. We saw here that we have microblaze CPU system, like instant logic units, and we have here, which is also mentioned, that we have microblaze RISC-V architecture. It is very interesting. I didn't have the opportunity to deal with the microblaze, even either it's RISC-V or microblaze CPU, but just referring to the previous mentions on previous slide. Also security units, we have SHA3, like here. Secure stream switch, custom via secure PL interface. Okay. Anyway, let's recapitulate with we have processing system block, which is first block that we mentioned, and inside of it should be eight A78 ARM cores, CPU cores with here is said L1 and L2 caches. Dual core CPU clusters. Yes, one cluster has two cores inside of it with local L3 caches. As we can see, yes, L3 cache is close to the A78. Each A78 has its own L3 cache, and we have clusters A, B, C, D, like it's mentioned here. Lockstep option within clusters that we mentioned that I think in first video. System level L4 cache per cluster. LSC. This is very interesting, and this is the first time that I see that we have L4 cache. SMMU that we mentioned before with coherent mesh network. We have interesting things inside of this. So processing system, it's one subsystem. Also, we mentioned that we have ACU subsystem, programmable logic, and PMC subsystem. This is third one that we mentioned. Uh, Also, we have here in first video we mentioned IE engine, and we have IE engine which is connected with the programmable logic. Probably this is rich in parallelism, this engine, but also it's connected to, let's say, adaptive logic. But we will see in further videos also network on chip interconnect between processing system and programmable logic, which means that network on chip interconnect make links between a different part of the system on the chip. So in first case we see between processing system and programmable logic, and also it's connected to the IE engine, and also with DRAM, which is DDRM C5A and the DDRMC5X. Actually, this is memory controller, but we will see the details because this Versal is have, I think, 754 pages of documentation, so we will see and check different parts of it. External DDR, so actually this is a DDR memory controller for the external DDR, which is probably not on this system on chip. So this is a connection for the data transfer with the external world with ECC interleavable. Okay. Also, we see here that processing system is also have some input-output connection with the external world, I guess. So it's important to say that it's not the programmable logic subsystem, and that it's connected on the that way on the with the external world. So I think this is enough for today. Once again, processing system, ACU subsystem, PMC subsystem, and programmable logic, and mentioned network on chip interface with the external DDRAM and GPU unit, and interconnections like Ethernet 10 gigabytes speed, also USB 3.2, and so on and so on. So I hope that you enjoyed video and that we describe more like in pictures than visually what this system on chip is consisting of. Also, SPD, we see that these green parts are the SPD, and I think that we mentioned it on a third chapter, but I'm not sure. We can check it. Let's go to yes, PMC is a chapter 3 which we mentioned. So no, it's SPD. Okay, but PMC is LPD. That's the third chapter, and processing system was full processing system was APU and RPU. So chapter 1 and chapter 2 was talks about processing system. Unfortunately, this diagram is, let's say, enriched with information, but description of the information we cannot. It's not easy to. It's not easy to put this in one place, but I hope that you can follow what's happening. Anyway, I will put the comments in the link with the specific explanation, so you can go on a timeline of this video on specific content which you need to know or want to know better. It's difficult to have this information all in one, but let's go with our head with the main topics: processing system, programmable logic, PMC subsystem, ACU subsystem, and so on, graphic subsystem, and then we will discuss in details all about these specific subsystems and go inside of them to describe them more closely, what they do and how to work with them on proper way. So once again, APU subsystem and the RPU subsystem are from the first video that we make. Okay, that's it for today, and have a nice day. And I don't want to bother you anymore. So I hope this was very interesting. Bye bye.